Nothing is more special than a bond with people who you choose to be family with. And this group of friends will prove exactly that. These high school friends consisting of Thosek, Christian, Knight, Claire, Jazreel, and Joshua all decided to finally reunite after 8 long years. They have their own lives now, and they are all extremely curious about how their friends are doing.
I can't wait to be with my friends again. It's been so long since I've been with them. Oh my god! Hi guys!
I miss you guys.
Same. I'm ecstatic to see you all right now.
How long has it been? 8 years? It feels like yesterday that we would have lunch together.
Right. Anyway, how are you all doing? Now that we've reunited here in New York, let's talk about each other.
One of the 8 friends, became a chef in his own renowned restaurant. It is very popular within the streets of New York. The restaurant has a wide variety of dishes, but his 2 most popular ones are the grilled pork chop and the fried chicken with tosse de la sauce. Every day, he has a set of dilemmas trying to figure out who ordered which. On one scrumptious day, he received 420 orders. Tosse solved who had ordered chicken or pork chop only and how many ordered both. There were 169 for pork chops and 369 for chickens.
Hello, Chef Tosse here, and today I will show you how I solved my dilemma in the kitchen. Solving for who ordered both, who ordered fried chicken with my special sauce, and who ordered grilled pork chop. Now, we will solve first who ordered both. Now to get this, we must do 369 plus 169 minus 420. So 369 first and plus 169. Combine those first before minusing it to 420. Now, it will result to 118 ordering both. Now, we shall solve who ordered chicken only with my special sauce. 369 minus 118 results to 251 customers ordering chicken with my special sauce. Now, to solve for the grilled pork, we need to minus 169 with 118. That will result to 51 grilled pork only. Now, here is my Venn diagram which shows grilled pork having 51, both being ordered results to 118, and fried chicken being the most popular having 251 orders. And I'm pretty sure it's because of my special sauce, which has spicy, sour cream, cheesy, and all of the other things you can think about sauces. This has been Chef Tosse, and I am now signing off.
The other 5 people of the friend group decides to buy from Chef Tosse's restaurant. Upon entering, they were immediately able to discern that it was a fancy 5-star restaurant. The group then finds a big table to sit for everyone. Looking at the menu, Knight discovers that there are 9 dishes currently available, 6 main dishes and 3 desserts. While everyone is busy trying to think of what to order, Knight ponders how many possible combinations of dishes is possible if they choose 1 main dish and 1 dessert. He keeps in mind that the order of the dishes does not matter.
This situation involves a combination with repetition. The formula for a combination with repetition is equal to quantity n plus r minus 1 factorial divided by r multiplied by quantity n minus 1 factorial. N is the number of things to choose from, choosing r of them. In this problem, n is equal to 9 and r is equal to 2. Plugging in the values into the solution, we get the final answer, which is 45. Therefore, there's a total of 45 possible combinations of food based on the menu.
After the friends ate, they continued to roam around New York.
Well, you've always been the cook of the group, so I'm not surprised. Congrats, Tose. We love your food so much.
Speaking of congratulations and surprises, it must have been shocking when you won the lottery last year, Josh.
Last year, Joshua was casually roaming around the neighborhood, greeting everyone he saw with a smile on his face. Suddenly, Joshua stopped and took a moment to look at a flyer about winning money through a local lotto shop close by. Joshua didn't have much to do on that day, so he told himself, "Why don't I try the lottery? I mean, it's relatively cheap and I don't have errands to run." And so, Joshua ventured to travel to his destination, the lottery shop. When he reached the lottery shop, he then checked the guidelines for entering the lottery. One of the guidelines mentioned that he had to pick 6 numbers from 1 to 50. Before Joshua participated in the lottery, he first had to calculate the probability of winning the lottery, whether the order does or does not matter.
Looking at our solution, let us first start with placing our respective formulas for both permutation and combination. Starting with permutation, the given formula is P is equal to n factorial all over the quantity of n minus r factorial. The value of n would be equivalent to 50 and the value of r would be equivalent to 6 because, as aforementioned, Joshua had to pick 6 numbers from a range of 1 to 50. N represents the total number of choices, whereas r represents the number of choices we can make. To make it clear, in comparison with both formulas, permutation is used where order is important and combination is used where order is not important. After placing our values, the factorials from the numerator and denominator provides us a ton of numbers, which makes it quite difficult to read. So I'll skip to reading the numbers. I apologize. After some painstaking calculations, I arrived at the final answer for permutation of 11,441,304,000. The probability of winning in this case, if I divided the result by 1, would equate to 0.00000000009%. Moving on to combination is quite similar with the formula of permutation. However, as you can see, the formula has now added an r factorial before the parentheses. Then again, same scenario with the previous one, our factorials provide us a ton of numbers. Nonetheless, I still managed to arrive with an answer, which is 15,890,700. The probability of winning in this case, if I divided the result by 1, would equate to 0.000000063%. So, after comparing the two, I've deduced that I would have a much better chance of potentially winning the lottery if I chose my numbers in no particular order.
Out of no uncertainty, it pours in the streets of New York.
I am Krisha Jane Saison, your weather reporter for today. Now let's see what the weather is like today. It will be very windy and cold. There will be 80% chance of rain until tomorrow, so don't leave your home without your umbrella. This is Krisha Jane Saison with the CNN weather forecast. Thank you and stay safe.
Another person from the friend group, Krisha, is now an amazing news reporter and weather forecast in New York. And she will be analyzing a record of the weather station for the past 365 consecutive days, having 135 incorrect weather forecasts. So now the question is, what is the probability of the correct weather forecast on the given day?
In In this situation, we are solving for the probability of the correct weather forecast for the station for the whole year. This situation is an example of experimental probability as the data was produced after recording the number of times the forecast was incorrect, and the results of the correct forecast was used to calculate the chances the forecast was correct. To solve this, we are using the formula of P, open parenthesis, days forecast was correct, equals the number of days forecast was correct over the days the record was available. 230 days over 365 days equals 0.63. Consequently, the station's weather was 0.63 or 63% correct for the whole year.
The next day, Jezreel asked his friends to play Monopoly with him, and he was very persistent to win.
Play Monopoly, cash fund and ritzy property.
Jezreel is an avid player of the Monopoly board game. It is one of the most popular board games in New York. The game has many ways to be played, making use of various strategies and antiques. But it all comes down to the rolling of the dice. The Monopoly board game makes use of 2 6-sided dice. Jezreel is in the best spot possible. 11 blocks away is the free pass. He needs to know the probability of rolling an 11.
The probability of getting a sum of 11 can be constructed into two events. Event A being 5 on dice 1 and 6 on dice 2, and event B can be 6 on dice 1 and 5 on dice 2. Now, we can construct a table from these two numbers. D1 under this will be 5 and 6, and under D2 will be 6 and 5. So basically, we can form the equation probability of event A plus probability of event B minus probability of A intersection B. Now, can we get a 5 on D1 and a 5 on D2 and still have 11? The answer is no. So that means that these two events are mutually exclusive. So therefore, probability of A intersection B is automatically equal to 0. Thus, we are left with two parts of the equation only, which is P of A plus P of B. So P of A, probability of A. Event A is 5 on D1 and 6 on D2. We have two probabilities to solve. Getting a 5 on D1 has a probability of 1 over 6, and getting a 6 on D2 also has a probability of 1 over 6. So what is the probability of getting these two together? Then we just simply multiply those two values. 1 over 6 times 1 over 6. And on the other hand, probability of event B is the same thing because we're still using the same dice, just with different order. So 1 over 6 times 1 over 6 is equal to 1 over 36, plus 1 over 6 times 1 over 6 is equal to 1 over 36. Then we are left with 2 over 36. And then we can simplify that to 1 over 18. Then that means we're done.
America is great because America is good.
Good morning, everybody. This is May Clara Sibo, Mayor of New York City, and I would like to personally thank you all for coming to this event and for celebrating our dear LGBTQ plus friends and family with us. I, as a mayor, am so proud to see all of your beautiful faces, and I am so glad that we all get to be here for not just tolerance but acceptance as well. Being a part of the LGBTQ community is not easy. However, times have changed. In fact, in the most recent trial done by our board members, 75% of our people support the LGBTQ community. This proves that change is not impossible and we can still make a huge difference. We can still convince the 25% of our people that the LGBTQ plus community deserve their respect. This is once again your mayor saying that we can conquer everything when we work together. Welcome to this event.
No one told you life was gonna be this way. Your job's a joke, you broke. Your love life's the old way. It's like you're always